It is often necessary to find the common solution to two or more equations. We refer to these equations as a system of equations. The solution to a system of linear equations can be found using a variety of methods. In this video, we will illustrate how to solve a system of linear equations using the substitution method. The system of linear equations that we will solve is written here. To begin the substitution method, we must solve one of the equations for one of the variables. It does not matter whether you solve for x or y in this first step. To determine which variable to isolate, then, we look in both equations for a variable with a coefficient of 1 to avoid fractions. In the first equation, x has a coefficient of 6 and y has a coefficient of 5. In the second equation, however, x has a coefficient of 1, so we will choose to isolate x in this second equation. To get x alone, we will add the 3y term to both sides of the equation. This will give us x alone on the left-hand side and 4 plus 3y on the right-hand side. This means that x can be thought of as equaling 4 plus 3y. Since I'm going to go now and use my first equation, I will rewrite it. As the name of the method suggests, what we are going to do is substitute the expression for x that we just found, 4 plus 3y, in place of the x in the other equation. 6 times 4 plus 3y plus 5y equals 1. This yields an equation in terms of only one variable. So now what I will do is use my algebra skills to solve for this variable. First, I will distribute the 6. 6 times 4 is 24, and 6 times 3y is 18y. Then I will continue writing the rest of the equation. Next, I will combine like terms. 24 plus 18y plus 5y is 23y. Then I will subtract 24 from both sides. This will give me 23y equals negative 23. And when I divide by 23, I succeed in isolating and solving for y. This gives me y equals negative 1. Remember, we are not done yet. We have successfully solved for one of the variables, but because this is a system of linear equations with two unknown variables, I have to find the value of x now. I go back and look at my original equations. 6x plus 5y equals 1, and x minus 3y equals 4. I choose one of these equations to substitute the value of y in. I will choose x minus 3y equals 4. And I will substitute negative 1 where I see a y. Now I will solve for x. I will rewrite my x. Negative 3 times negative 1 is positive 3. And I will subtract 3 from both sides. This yields an answer of x equals 1. To express my final answer correctly, I will take each value found and write them as coordinates of an ordered pair. Since an ordered pair is expressed as x, comma, y, I will list my x value first, which is 1, and my y value second, which is negative 1. 1, negative 1 is my solution to the system of linear equations given here. It is the solution because it satisfies both equations in the system.